Okay, so far everything we've talked about are all the basics. Okay, all the equations for equilibrium, rigid bodies versus particles, and all that. Those are the foundations, right? Those are the theory, and it's extremely important. Okay, make sure that you're really comfortable and familiar with, the theory and the math behind it. Now, for the rest of the semester, we'll talk about applications. We're going to apply everything we've learned so far into real-world structures. Okay, beginning chapter 6. Okay, I'm going to talk about structural analysis. Now, this chapter is split into two parts. The first part, which is really the bulk of it, is called a truss. Okay. And the second part, frame of machines. They're quite similar. The major difference is, for a truss, we're dealing with two-force body, okay, two-force rigid body. Okay, if you recall, in the last chapter, talked about 2- and 3-force rigid bodies. Well, here it is. The two-force bodies, okay, are basically what make up a truss. If a frame of machines, there are 3 or more force bodies. Okay, so we'll talk about this later. But first, about truss. A truss could look something like this. Okay, it's just a bunch of rigid bodies connected together. Okay, for each piece of rigid body, it's called a member. The point where 2 or more rigid bodies, okay, 2 or more members are joined together, it's called a joint. Okay, so a truss simply just is made out of a bunch of members and a bunch of joints. That's all. So this is just one of many, many examples of a truss. Okay, so this truss is made out of these members like that, and then here in the middle of the truss we have, in the middle of this member we have another member connecting to it. Right? Now, a subcategory of truss is called simple truss. It's simple because, well, compared to this picture to this picture, this is simpler than that because here, for a simple truss, all the forces, okay, or loading are applied at joint only. Okay, and it could look something like this. Versus the more general truss. Up here, for this member right here, the loading occurs at this point, at this joint right here, and this joint, as well as somewhere in the middle. Okay, and also I could actually apply an external force, right in the middle of this member right here. Right. So in this case, that's not a simple truss. A simple truss is where all the forces are applied at joint only. Yeah, here I've labeled all the joints A, B, C, D, and E. Okay? So, based on this definition, the result is each member is a two-force rigid body. Okay, it's a two-force member. Okay, so being a two-force rigid body, so I can just draw this member AB, for example, okay, and draw the forces on it. Now, since each force is applied at a joint, okay, so I have this force coming this way, and then the other force coming the other way. Okay, so it's a two-force body, and the requirement for a two-force rigid body is that these two forces must be acting along the same line of action. Okay, which means that they have to be pointing along the same direction as this AB member is oriented. Okay, if this AB is, let's say, a 45-degree angle, then FAB must also be 45-degree angle. Okay, and that other force must be acting opposite to this force direction. Okay, so that in the end they both cancel out. So that in the end, this member AB will be in equilibrium. Okay? So there's no net force and no net moment either. So the result is AB being in stationary condition, okay, equilibrium condition. Okay? So with that said, you can compare these two cases right here. Right? This case and this case, they're both two force members, right? AB with these two forces coming in this way. The bottom picture is also two force, okay, picture, but with the two forces pointing away from this rigid body. And they're both okay, and they are completely opposite from one another. In this case, it's called compression loading, okay, where both of these forces are acting toward each other, creating a tendency to compress this member AB. Okay, that's why this force FAB is called compressive force. This bottom picture shows that this force AB is a tensile force. Okay, so this member AB is under tension. Okay, so in a simple truss, there are only two possible loading situations. It can be either under compression or tension. Okay, each member can only be under compression or tension.